Good morning, kids. I'm Sridhar, sir, your physics teacher. Today we are going to discuss the 2nd April, the shift to the evening shift, JEE Mains 2025. A physics paper. The complete paper solutions will be available here. First, what about the level of paper we'll discuss? Paper is moderate, formula based, and heavy calculation. Most of the problems you have to apply the formula, then solve it, then you reach that one. So that is a basic thing, and number of questions which are easy 8, just simple theory and substitution type. Moderate questions where you have to take formula, little bit derivation you have to work out. Tough questions 2 are there. Total, this is the paper strategy. The paper you can put it in order of the moderate paper. Those who are like a 3rd April, 4th April, then the one who are writing on the 7th and 8th one. What is the simplest methodology is like a read how much all possible, recollect all formulas. Definitely you can do very good in exams. That's all. No need to panic anything. No need to panic. Especially physics, read concepts and revise formulas. Read concepts, revise formulas. Okay, fine. So we'll start the paper discussion. This topic is based on the current electricity chapter. Then subtopic is galvanometer. So he's asking, let's read the question. Two galvanometers G1 and G2 are having resistors R1 and R2, number of turns N1 and N2, magnetic fields present in galvanometer, and area of cross section of the coil. And same figure of merit. Find the ratio of their voltage sensitivity. Then directly we'll go for the torque equal to NIAB, where torque equal to K theta. There's a from galvanometer you have to recollect. Then current sensitivity, I'll use SI, which is equal to theta by I, which is equal to NAB by K. Voltage sensitivity, theta by V, which is equal to theta into IR, which is equal to now how much? NAB by KR. K is the figure of merit. There's a formula. If you remember formula, okay, fine. Without formula, you can't solve this problem. I was asking the ratio of this one. SV1, ratio of the voltage sensitivity. It will be equal to N1 A1 B1 by KR1, N2 A2 B2 KR2. So this everything will become N1 A1 B1 R2 by R1. So ratio of N1 by N2, 21 by 15. A1 by A2, here only 3.6 by 1.8. B1 by B2, 0.25 by 0.50. R2 by R1, 7 by 5. Solving this, we'll get this the answer. There's a formula you must know. If you know this formula, you can do something. Otherwise, not possible. Voltage sensitivity, current sensitivity. Then formulas are very important. You must know the theory and the formulas. Okay, we'll take the next question. This question, second question, is based on the chapter Heat and Thermodynamics. The subtopic is calorimetry. The subtopic here is asking you to match the quantity with the is particular SI unit. Heat capacity. First, we'll start with the specific heat capacity. The specific heat capacity we define it as dq by m dt. This will become joule kg per Kelvin specific heat. So therefore the specific heat here, there's a quantity. Heat capacity. What do you mean by heat capacity? Mass into heat capacity, mass into specific heat. This will be dq by dt. This should be equal to joule per Kelvin. Okay, these two are rolled out. Between these two, we'll check it. Latent heat, Q equal to ml. Latent heat will be Q by m. This will be joule per kg. This will be latent heat. So therefore, this should be your option. The definitions, just formulas, definitions. You must know thermal conductivity, already you know that one. Thermal conductivity will be dq by dt, Ka temperature difference by L. dq by dt, this will be watt, K, L square, meter square, temperature Kelvin by meter. So thermal conductivity will be, there's a thermal conductivity, so the dimensions of this will be, the unit for that will be watt per meter per Kelvin. Okay, done. There's a one basic method, just definitions, thermodynamics definitions. You must know the thermodynamic definitions, all the calorimetry concept. If you know the basic definitions, you can do this problem very easily. I'll take the next question. Here the next question. Chapter is units and dimension, the name of chapter, and the topic is electromagnetism. It's asking about some dimensional analysis. The question: in a system of measurement, electric charge Q, permeability mu naught, and electric current I are considered as fundamental quantity. The dimensions of linear momentum of this system is. So we have to express the linear momentum in terms of charge, permeability, and electric current. So for that, the linear momentum, this should be proportional to charge A, permeability B, and the electric current C. What are the dimensions of the momentum? The dimensions of momentum will be mass into velocity, m1, l1, t minus 1. Dimensions of charge will be current into time, I1, T1. Dimensions of mu naught, permeability, this will be M1, L1, T minus 2, I minus 2. Okay, fine. So here this will be current will be I. Okay, these are here. Okay, we'll simplify. I will be A minus 2B, or say, okay, first we'll start with M1. MB, LB, T will be A minus 2B, I will be A minus 2B plus C. Equating powers, we'll equate the powers. The dimensions of the M, you check it here. So B equal to 1. L also L also from here. Then for T will equate like this. A minus 2B equal to minus 1. as b equal to 1. So 2 into 1 minus 1. A equal to how much? Will be 1. Now a minus 2b plus c equal to 0. The dimension, see. Here we can write it like this. I into 0. This is very important. Then a value is 1. B value is 1. Then we'll get c. C will be 1. So the dimensions of momentum will be, this will be q mu naught I. This will be our option. Based on dimensional analysis, electromagnetism, dimensional analysis here to do it. We'll take the next question. Chapter name is Heat and Thermodynamics. The question belongs to Heat and Thermodynamics. And the subtopic is in thermodynamics, the basic process, the adiabatic process. So you should know the concepts of just the theoretical idea of what is adiabatic process if you know. So you know that in adiabatic process Q will be 0, then W equal to minus delta U, and PV gamma equal to constant. TV gamma minus 1 equal to constant. And what is the work done formula? Work done will be equal to minus NR gamma minus 1 T2 minus T1. So work done will be proportional to mod of T2 minus T1. This is a valid thing, this is a valid thing. Delta U 0, wrong thing. PV to the power of gamma equal to constant. TV gamma minus 1 constant. So only these two are valid. So we'll pick up this option. Simple adiabatic process definition, if you know it also, you can manage here. I'll take the next question. This question belongs to the chapter Waves and Sound. The topic is traveling wave on a string. A wave is traveling along a string. The wavelength of the wave is 7.5 meter and amplitude is 2 centimeter. So here we have the basic, and this is the wave. It travels along this one, and this is a crest. This is a y, this is x. At x equals 0, and there is a crest at x equal to 0. And I'll change the thing. There's a crest, and what is the condition given? The wavelength, this will be the wavelength. The distance between two crests will be the wavelength, and the amplitude given 2 centimeter. Lambda is 7.5 meter. So if you know the lambda, so we can calculate the k equal to 2 pi by lambda. 2 pi 7.5, 15 by 2, or 4 pi by 15. Per meter it is there's a value of k, propagation constant it is. Then we know the amplitude. Then at t equal to like a 0, the crest is at amplitude of 2 centimeter. So definitely what happened, we have to take the cos equation, and the wave is propagating along positive x-axis. So for that we don't know omega, but he has given some information. The crest will travel distance of 12 centimeters, 0.3 seconds. We'll get the wave speed. What is the expression for wave speed? It will be distance covered by in time. This will be 120. This in centimeter per second, or 40 this will be expression for wave speed, 40 centimeter per second. We'll calculate the omega. Wave speed is defined as omega by k. Wave speed is 40. Omega we don't know. The k value is 4 pi by 50. So this will become 0.4. Solving this will get omega as 8 pi by 75 per second. Now we'll write down the wave equation. Y equal to a cos kx minus, why kx minus omega t? Because the wave is propagating along positive x-axis. We know the amplitude 2 centimeter, we know the value of k, we know the omega, substitute, we'll get this one. Second one will be the option. And this particular thing is a rope or it will be a string. Okay kids, we have this question belongs to chapter ray optics and the topic is lens. Let me read question. An equiconvex lens of radius r equal to 1 by 6 meter is having power p. Another biconvex lens of radii r1 and r2 is having same power p. Then is asking us to get the ratio suitable values for r1 and r2. What do you mean by equiconvex? It will have the same radii, refractive index. Let the and it will form the image here. This will be the focal length. There's a basic idea. What is the formula for equiconvex lens? 1 by f1 equal to mu minus 1 by r minus of minus 1 by r. Why negative sign? Because this will be positive one. The radii of this will be positive. You are measuring in the direction of incident ray. The radius of curvature of this you are measuring opposite to incident ray. Therefore, this will be negative. So this will become 1 by f1 mu minus 1 2 by r. Okay, this radius how much given? 1 by 6. So this will become mu minus 1 into 12. Next, biconvex lens. It is having different radii, R1 and R2. Ray incident, it will have the focal length f2. Different radii it is having. Then what should be the formula for this? 1 by f2 equal to mu minus 1 by r1 minus 1 by r2. Just based on the lens maker formula. Having same power means f1 equal to f2. So substituting this value here, 12 mu minus 1 1 by r1 plus 1 by r2. 12 equal to 1 by r1 plus 1 by r2. So choose some values of r1, r2 which will satisfy these options. Okay, it will satisfy this one. 1 by 9 plus 1 by 3, if you choose it, it will satisfy this equation. There's a based on the power. Power means reciprocal of focal length will be power. There's a concept. Now we take the next question. This question belongs to the chapter Electromagnetism or Moving Charges and Magnetism. And the topic is solenoid. The topic is solenoid. So let me read the question. The area of solenoid is A, length is L, magnetic field inside is B0, and the relative permeability of the medium is 2. The energy stored due to the magnetic field is. So it is something related to solenoid, the solenoid. Rough diagram. In exam, you need not to draw the diagram. There is a solenoid carrying current I. It will generate a magnetic field. It is having length L, area of cross section A, and it will produce magnetic field B equal to mu naught Ni. Now it is asking about the B naught is a magnetic field. It's asking about the energy stored due to magnetic field. Magnetic energy is equal to energy density into volume. What is the energy density formula? B naught B square, B naught square by 2 mu naught. Magnetic field inside the area of solenoid is A. Length is L. Magnetic field relative permeability here. Okay, this one. There's a mu. Now further, what is the formula? We know the mu should be equal to mu naught into mu r. What is the relative permeability? He has given this is equal to 2. So this will become 2 mu naught. So this will become B naught square AL. So this will be B naught square AL 4 mu naught. Simple idea. Energy density. The formula for energy density will be B naught square or B square by 2 mu. In free space it will be 2 mu naught. In any medium it will be 2 mu naught into mu r. Mu r will be relative permeability, and the relative permeability of medium is how much given? 2. Just theoretical things, nothing big. We'll have the next question. The question belongs to the chapter surface tension. The topic name is surface energy. The idea of surface energy is being stressed here. Two identical drops of radius r and surface tension T coalesce to form a bigger drop. The change in surface energy in this process. Change in surface energy is asking. There's a one drop of radius r. The two drops will coalesce to form a bigger drop of radius r. Right? Is asking the change in surface area, that one. So first the volume should be conserved, mass, total volume, the mass should be conserved. So rho into 2 times 4 by 3 pi r cube. This should be equal to rho into 4 by 3 pi r cube, where r is equal to 2 to the power of 1 by 3 into r. Keep this value like this. Then initial energy. Here initial energy. This is the final surface energy. What is the initial energy? The initial energy is, there's a drop, it will have only one surface, and there are two drops are there. 2 times surface tension into 4 pi r square. So this will become 8 pi st r square. Final energy. Final energy will be surface tension into 4 pi r square. R square will be this will become st 4 pi 2 to the power of 2 by 3 r square. The final energy will be 4 pi r square st 2 to the power of 2 by 3. The difference is asking the change in surface in the process. So you have to take the difference of these two. So if you see the difference, delta E equal to EI minus EF. 8 pi r square st, 4 pi r square st 2 to the power of 2 by 3. If you take 8 pi r square st outside, here it will be 1 minus 8 pi r square st, 1 minus 2 to the power of minus 1 by 3. Change is asking, so you can pick up this one. A simple idea. So you must have this conservation of mass. Mass of system remains same. This is a basic idea. We'll go for next question. This question belongs to the chapter electrostatics. The topic is electric field due to ring, E bar due to the ring. There's a uniformly charged ring of radius r charge q. At what distance on the axis? This one is the axis, where the field will be maximum. We know, I think everyone knows this. I need not to explain. The graph will be of like this. At one point, there's a graph, there's a variation of E as a function of X. Exactly at R by root 2 on either side, it will be maximum. Then what is the expression for the electric field strength? In general formula, KQ X by R square plus X square to the power of 3 by 2. This is the expression for the electric field produced by the charged ring. Differentiating this equal to 0, we'll get X equal to plus or minus R by root 2, where this is X equal to 0, where the field will be maximum. And there's a direct question from electrostatics, E bar due to the ring. Okay, from this graph you are able to understand. So some theory, you must read theories. Reading the total chapter is very important. Read or watch one shot, or teacher notes you'll be having. Read that one. Then afterwards recollect all the formulas. Then definitely you can do better in exam. Without reading, now not possible. Without reading, without memorizing, sir, I'll manage exam, not possible. So we'll have next question. We have the next this question belongs to the chapter nuclei or nuclear physics, and the topic is based on the binding energy. Binding energy per nucleon of the this one deuterium is X, that of the helium nucleus is Y. Find the energy relieved in the given reaction. So two deuteriums combine to form the helium. Binding energy, or better you can call this as fusion reaction. So is asking which particular equations is suitable. Then these are called as parents, and this is the daughter. Then what is the basic idea? The binding energy per nucleon, we know it. So how many nucleons are there here? 2 and here 2. And how many nucleons? Here it will be 4. So we have to calculate the binding energy per nucleon. So there, what is the binding energy per nucleon of the daughter? Binding energy per nucleon of the daughter, it is Y. How many nucleons are there? 4. So therefore 4 nucleons into binding energy per nucleon will be the binding energy of the daughter. So the energy released, this is the energy released. The energy released equal to binding energy of the daughter minus parent. If they give mass of the parent minus mass of daughter should be the energy released. Two formulas are there. Q equal to mass of parent minus mass of daughter C square, or binding energy of daughter minus binding energy of parent. If they give information of mass, use this formula. If they give information of binding energy or binding energy per nucleon, use this formula. So what is the binding energy per nucleon? Y. How many nucleons are there? 4 minus. Then here two atoms, 2 nucleons are there. Then binding energy per nucleon of the deuterium, how much it is x, and it is having 2. So this will become 4y minus 4x. This will be your option. So there's a concept. Mass of parent minus mass of daughter into C square will be energy released. Binding energy of daughter minus binding energy of parent will be the energy released. And we have information of binding energy per nucleon. Multiply with number of nucleon, we'll get the binding energy. The difference in binding energy will be the energy released. Okay, we'll move to the next question. This question belongs to the chapter capacitor and the topic is electric field and potential difference across the capacitor, just based on the basics. The figure shows the plates of parallel plate capacitor with a separation 10 centimeters. There's a one plate. Okay, fine. Next again, with a separation how much? 10 centimeters. And charged to a potential difference V. What is the potential difference? V. Find the potential difference between B and A. And how the electric field vector, how it will be is very important. Here the electric field vector will be in this direction. I'm drawing brown color lines, that is the electric field vector. And how the equipotential, A and C are at same potential. VA equal to VC. So therefore VA minus VB is equal to VC minus VB. And resultant electric field. How you define the electric field vector? Potential difference V by 10. And the electric field vector has to be same. So the electric field vector should be VC minus VB by 4. Is asking about the this VCB. VCB is equal to, this will be V by, here only I'll substitute, V by 10, VC minus VB by 4. So VC minus VB should be equal to 2V by 5. What is VCB? Potential difference between points C and B. The potential difference between points B and A or B and C will be same. Because potential at A equal to C, the reason, because A and C will lie on the equipotential lines. This will be equipotential line. This will be equipotential line. Simple based on the electrostatics, the idea. In uniform electric field, potential difference should be equal to E into delta X, where delta X is measured in the direction of electric field. This is the concept. We'll jump to the next question. Here this question belongs to the chapter rotational motion. And the topic is torque and angular acceleration. Here is a circular disc of mass m, radius r. It's hinged, this point O is hinged, keeping axis horizontal. This is the horizontal axis. If angular acceleration of the disc, we know the angular acceleration. Find moment of inertia. We applied a force. This force will set up a torque. So here, torque equal to I into alpha. What is the torque set up by this applied force? F into R. Moment of inertia is asking. What is the value of F? 10. This will set up a torque. This force F into R will set up torque about 0.0. So what about the weight? The weight mg is acting, but it will intersect axis of rotation. This is the axis. It will intersect axis of rotation. So therefore the torque by the weight will be 0. Only torque is set up by the applied force. So 10 into R. R is 2 meter. Moment of inertia. Angular acceleration 2. So moment of inertia will be 10 kg meter square. Simple. Somehow you should know this torque equal to I alpha. And just basic idea how torque is set up. F into R. So we'll move to the next question. This question belongs to the chapter Laws of Motion, class 11 syllabus. Topic name is tension in a string. Here you can see the string here. Two strings we have. There's a one string. Next we have the other one. Find the ratio of tension in these two strings. Then what are the forces they'll be acting? The weight mg. One component, and it's in equilibrium. Rest is telling it will be at rest. Then the net force along y-axis should be 0. T2 sine 60 degree, T1 sine 30 degree equal to mg, or T2 root 3 by 2, T1 by 2 equal to mg. Along x-axis, net force along x-axis should be 0. This is net force along y-axis 0. Similarly, at equilibrium, net force along x-axis must be 0. So T2 cos 60 degree, here T1 cos 30 degree should be equal to 0. At equilibrium, the net force along x, along y should be 0. So along x are liquid forces, T2 cos 60, T1 cos 30. So he's asking the ratio of tension, T1 by T2, cos 60 degree by cos 30 degree. This is T1 by T2. Cos 60 is 1 by 2, cos 30 is root 3 by 2. So T1 by T2 will be 1 by root 3. A simple idea-based question based on the equilibrium of the bodies. In laws of motion chapter, we do come across equilibrium of bodies. And what about the tension? Tension should always act away from the body. So all these ideas we have applied it here. So we'll move to the next question. Okay, this question belongs to the chapter rotational motion. The topic name is moment of inertia. So I have the ring, circular ring of mass m and radius r, where O is the origin, which is lying at the center of the ring. The moment of inertia of ring of mass m and radius are about an axis passing through tangential point in the plane of the ring. How the axis? The axis will be passing, will be tangent and will lie in the plane of the ring. I think it's all about the language. Through tangential point in the plane of the ring. Means about IBB dash, the moment of inertia we have to find out. Applying parallel axis theorem, IYY dash plus m into r square. This will be the moment of inertia. Because what is YY dash? It is an axis passing through the center of mass. So moment of inertia about axis BB dash should be equal to IYY dash plus m into square of perpendicular distance between those two parallel axes. So what is IYY dash? Again applying perpendicular axis theorem. IZ equal to IX plus IY. We know IZ, mr square. What do you mean by IZ? Moment of inertia of the ring about axis passing through center and perpendicular to its plane. It should be equal to mr square. And about x and y axis, it will be symmetric. So 2y it will be. So what is Iy is equal to mr square by 2, or this is nothing but Iyy dash. This is m r square by 2 mr square. Total it will be 3 by 2 mr square. This will be our answer. I think only the language issue here. You should be very particular about this sentence. This sentence will help you to assume this diagram. It's based on the parallel axis and perpendicular axis theorem. Those theorems you should know how to use it here properly. We'll move to the next question. We have the question from kinematics chapter, and the topic is motion in one dimension. It is asking about the distance and displacement. Particle, it will start at point A. It will move A to B, then B to A. Then it moves from A to B. What is the displacement? Displacement will be only 2 meters. Shortest distance measured between initial and final points will be 2 meters. Then A to B, B to A. What is the total distance covered? Will be 4 pi r. Radius of the circular path is 1 meter. So the distance covered A to B, B to A will be 2 pi r, pi r plus pi r, 2 pi r. 2 pi will be SABE. Then what about the displacement? Displacement will be A to B, displacement will be 2 meter. It should be 2 pi. Total distance going to be 2 pi and the displacement will be 2 meters. Just simple based on the definition of distance covered and displacement. Distance covered is a scalar, we have to add up the total path length. Displacement is shortest length measured between initial and final points. We'll move to the next question. We have this question from the chapter ray optics, and the topic is prism in that minimum deviation idea. So there's an incident ray, it will make angle of incidence I, the refracting angle R1, here angle of incidence R2, and the emergent angle is, let it be E. Then at minimum deviation I should be equal to E, angle of incidence should be equal to angle of emergence, and the refracting angles R1 should be equal to R2, and we know R1 plus R2 is equal to E, to R1 equal to A. I think these are all some minimum deviation, you know it. And what is the formula for minimum deviation? Mu equal to sine of A plus delta minimum by whole divided by 2 by sine of A by 2. We know mu. Equilateral prism, angle this will be 60 degrees. Delta minimum we don't know. So solving this, minimum deviation is 30 degrees. What is that minimum deviation? It will be here. So what is this minimum deviation? Is equal to I plus E minus A. And we know at minimum deviation I should be equal to E. So what is the delta minimum? Delta minimum already we know 30 degrees. To angle of prism 60 degrees. So it will, angle of incidence will be 45 degrees. Now these are the concepts of minimum deviation. Sir, what is this equation, from where you brought it here? The deviation suffered by the ray should be equal to incident angle plus emergent angle minus angle of prism. I think this is a general derivation you must know. Or you can also do one thing. We know mu, you can calculate the I here, because at minimum deviation or sin I equal to mu sin R1. At minimum deviation R1 will become equal to A by 2. So sin I equal to mu sin of A by 2. Substitute this, solve, will get answer. This is another method. You can use this or this one. Directly apply the Snell's law of refraction at the point of incidence. Sin I is equal to mu sin R. And at minimum deviation R1, R2, R1 should be equal to A by 2. Already I derived it here. Substitute this. That is, so sir, I don't know this concept. Okay, fine. At least apply Snell's law, and at least you should know at minimum deviation R1 equal to R1 equal to R2 equal to A by 2, and I equal to E. We'll move to the next question. This question belongs to the chapter units and dimensions. In that subtopic will be EM waves. Means something in the units and dimensions. Based on EM waves, the question is asked here. What is the dimensional formula? 1 by mu naught epsilon naught, where mu naught is permeability, F naught is permittivity of free space. It's asking to get the dimension. I think you directly know this formula. The speed of light will be related to the permeability and permittivity by using this particular formula. Then this should be c square equal to 1 by mu naught epsilon naught. It's asking dimensions of this. What are the dimensions of c? Speed, L, t minus 1. So square of that. So you should know this from the EM waves chapter. The speed of light will be related to permeability, magnetic permeability and electric permittivity by this particular formula. Then you can analyze this question very easily. It's not something like you should uh, derive this. It's a memory what you must know. So we'll move to the next question. Okay, the question belongs to the chapter atoms, and the topic is radius of n Bohr orbit of hydrogen and hydrogen-like atoms. So we have the generalized formula Rn is equal to n square a naught by z. Z is the charge of the nucleus, n is the quantum number, a naught is the Bohr's radius, whose value is 0.53 angstroms. Z for hydrogen atom will be 1. For lithium double plus, Z will be 3. The radius of first Bohr orbit, lithium double plus to that of the hydrogen, n square a naught by 3, n square a naught, 1 by 3. Is asking to get the value of x. X will be 3. Now we'll move to the next question. Now we have the question based on the elasticity. The topic is Young's modulus. So the question is the length of the string is 104 meter when the tension in it is 5 Newton. The length becomes 1.56 meter when the tension in it is 7 Newton. The natural length of the string. We know Young's modulus equal to stress by strain, tension T1 by A. X1 is elongation and L0 is natural length. So strain will be change in length by original length. Stress will be force per unit area. Tensile stress, longitudinal strain. Similarly, when the tension is T2, the elongation will be X2 and the Young's modulus of material will be constant. What is the elongation? Final length minus initial length. What is the elongation? Final length minus initial length. So dividing this one, T1 by X1 equal to T2 by X2. The basic equation, T1 by X1 equal to T2 by X2. T1, what is X1? L minus L0. What is X2? L2 minus L0. We have to calculate the L0. So T1 L2 minus T1 L0, T2 L1 minus T2 L0. T1 L2, T2 L1 is equal to T1 minus T2 L0. The derivation, if you know this, that you can use this in exam, or else you have to derive here. We'll move to the next question. Okay, this question belongs to chapter ray optics based on the spherical mirrors. Let me read. A concave mirror and a convex mirror, same focal length. These are having same focal length f. A real object is placed in front of the mirror at a distance equal to half the focal length. So the object is placed at a distance f by 2 in front of the convex mirror. Similarly, for convex mirror also, the object is placed at a distance f by 2. The ratio of magnification in the image produced by the concave mirror to that produced by the convex mirror. So first we'll calculate the object distance. We'll use the mirror formula. 1 by V1, 1 by U1 equal to minus 1 by f. For the concave mirror, this will be f by 2 minus 1 by f. Why negative sign? Focal length will be negative. So 1 by V1 equal to 1 minus 2 by f minus f. V1 equal to f by 3. So magnification will be minus of V1 by U1. V1 will be f by 3. U1 will be minus f by 2. Will be 2 by 3. Second, for convex lens, 1 by V2 on the formula here some mirror formula. This will be positive, this will be negative, minus 2 by f. If you send here plus 2, V1 will be only F. Magnification will be 2. Next, mirror formula for the convex mirror, 1 by V2 minus U2 equal to plus F. Because this will be direction of incident ray. So 1 by V2. So this will be F by 3. So then magnification M2 equal to minus of V2 by U2. V2 will be minus F by 3. This will be minus F by 2. 2 by 3. It's asking the ratio of magnification. M1 by M2. 2 by 2 by 3. Or else you can directly use the formula. Instead of this, no sir, this lengthy, you can directly use this formula. Magnification. Substitute F and U with sign. Either of approach. See, somehow you should learn things. Once you learn, read, remember formula, then you have plenty of ideas to solve the problem. When you don't read, then nothing will come. We'll move to the next question. Okay, this question belongs to the chapter Semiconductor Physics, and the topic is logic gates. In the digital circuit shown in figure, for the given inputs P and Q, values, for the given inputs, the P and Q values are, for the given inputs, the P and Q values are. So here, what are the inputs here? 1 and 1. It's asking what is the possible output P and Q. So these are the inputs. I'll show here. These are the inputs. So we'll proceed here. This is a 1. This will be 1. This will be 1. It's a NAND gate. Output will be 0. When both are high, when both inputs are high, the output will be low, that one. So this is a NAND gate. Then the 0 is available here. Now come for this one. This is a jump, no connection here. Here 1, this will become 0. This input is high, this will be 1. This is a complementer, will do complementation. So I means will become low, will become 0. And there is an OR gate. If both inputs are low, the output will be low. Now we are having 0. The complement of this will be 1. Then this will be 1. Sorry, this will be 0. Here connection like this, this will be 0. For the AND gate, when both inputs are low, the output will be low. Then this is the NOR gate, the output will be low. So the value, this will be 0, this will be 0. We have to trace out almost all gates here out. OR, AND, NAND and NOR. Just you should know the basic logic operation of these fundamental gates. We'll move to the next question. Where this question belongs to the chapter Matter Waves and Electromagnetism. Is asking about the, based on these two topics, moving charge particle in magnetic field, deflection of moving charge in magnetic field, and its associated de Broglie wavelength. The particles, so let me read the question. Electron with mass m with an initial velocity v equal to v naught I cap moving along x-axis enters a magnetic field where b bar is along y-axis. If the initial de Broglie wavelength at t equals 0 is lambda naught. What is lambda naught? Lambda naught should be equal to h equal to mv naught. Then its value after time t, after some time t. Okay, we'll see what is the F equal to QEB formula. B bar velocity, so the force acting on this will be in this direction. Because of force and velocity, the charged particle will deviate like this. the charged particle will deviate. So as it deviates, its speed will not change, and this will be 90 degree all the time. The speed of charged particle should not change. I think there's a one very fundamental thing, and all the time FB will be perpendicular to V naught, because magnetic force cannot do work. We're going to move in a circular path. It will move in an exact plane. So the speed of particle will not change. So the de Broglie wavelength remains same as it is. Simple idea. Because work done by magnetic field is zero. No change in kinetic energy. Speed remains same. Speed remains same. The wavelength will remain same. Now we'll move to the next question. Okay, kids, we have this question belonging to chapter gravitation, and the topic is energy of satellite. Let me read question. A satellite of mass 1000 kg is launched to revolve around the Earth in an orbit at a height of 270 km from the Earth's surface. Kinetic energy of this satellite in this orbit. He has given mass of the Earth, radius of the Earth, and gravitational constant. So as the satellite revolves in circular path of radius r, will provide required centripetal force, the gravitational attractive force. So this should be equal to ms v naught square by r. This will be g, the gravitational attractive force, gravitational constant, mass of the Earth, mass of satellite, r square, ms v naught square by r. Or the orbital speed is given by gme r. Gme, the small r will become re plus h. What is the radius of orbit? Radius of orbit will be radius of the Earth plus the height of the satellite from the surface. This will be surface, no? This is h. So the radius of orbit will be radius of the Earth plus height. We're asking the kinetic energy of satellite, which is mass of satellite, v naught square by 2. V naught is orbital speed, ms by 2. This will be gme re plus h. Mass of Earth, mass of satellite by 2 times, in the denominator 2 into multiplied re plus h. Calculations: mass of the Earth given, mass of the satellite given, radius of the Earth given, height given, substitute, will get the kinetic energy. A very good problem. Just if you know the orbital speed directly, you must know in exam this one. I just shown the derivation. You must know this. You have to start from here. No need to no need of diagram also. I will get answer this one. Okay, this question belongs to the chapter Quantity of gases. The topic is ideal gas equation. We are asking to, the question is the internal energy of air in 4 into 4 into 3 size of room at 1 atmospheric pressure will be. Consider air as diatomic gas molecule. Inside this, the air is present. We have to calculate its intensity. What is the formula for intensity? NR NFR T by gamma minus 1. nRT F into gamma minus 1. We'll keep like this. And from ideal gas equation, PV equal to nRT. In place of nRT, I'll write PV. So PV F gamma minus 1. Pressure 1 atmosphere. 1 atmospheric pressure is how much it will be? 101 kilopascal. Or 10 to the power of 101 kilopascal or 10 to the power of 5. Volume will be 4 into 4 into 3. Degree of freedom for diatomic gas 5. Gamma will be Cp by Cv. Cv will be diatomic gas 5R by 2. Cp will be 7R by 2. Will be 7 by 5. Solving this, substituting all, we'll get the internal energy. Okay, fine. This is about the basic idea. Okay, kids, we had a complete paper discussion. And the paper is moderate, formula based, and heavy calculations already explained. You might have seen like a lot of calculations involved. So all writing the shift like a 3rd April, 4th April, 7th and 8th. What is the basic requirement of once again? Read the theory, start reading it, and daily recollect the formulas. Those who are writing on the 4th, now like a tomorrow will be the 3rd. Those who are writing on the 3rd, okay, night how much 1 hour possible, 1 hour physics, chemistry, math, you read it. Those who are writing on the 4th, you have advantage. Start reading, recollect all the formulas, check yourself. Do you know this formula? No. Do you know this formula? No. Are you able to remember this formula? No. Like that, what when you recollect, don't solve any problem. Only recollection. Reading and recollection. Reading and recollection. Reading and recollection. Okay, kids, will end up this paper discussion. Almost all the 25 questions I discussed here. So please do learn and put effort. Do hard work. There's a last attempt. There's no other choice. Okay, all the best. Those who are writing on the April 3rd, 4th and April 7th, 8th, all the best. Okay, thank you all of you. Thank you for great support. Thanks a lot.